Hi everyone. So this video is about binomial expansion. So we have seen elements of binomial expansion thus far. If you think about what a binomial is, it is an algebraic expression that has two terms in it. So we most often will see binomial expansion with that binomial, two terms inside a set of brackets raised to some power. So we have seen that in the past when we would do something like this. So when we did the FOIL section, we would rewrite that out twice. We would do first, outer, inner, last, FOIL it out to expand it. Potentially, you also may have learned the shortcut, which is this. You square the first term in the set of brackets, and that gives you your a squared. To do the middle term, you multiply the two together, and then double it, times it by 2. And then the third term is that third term, or the second term in your sets of brackets, squared. So this would represent term A, that would represent term B. So we've seen that. In our previous section, you may have also seen something like this, in your questions, where you would multiply that out 3 times. And you would FOIL the first two, and then whatever that turned out to be, then multiply that by that third set of brackets. So that's another form of binomial expansion. So basically, we're multiplying out single set of brackets that has two terms to a given power. So, like there is a shortcut for when it is to the power of 2 that some of you may have memorized or understand already. There is also a shortcut for the power of 3 and the power of 4, and they look like this. And some of you may have seen that before, and some of you may have that memorized already. What today's video is about is a shortcut to get to these without having to memorize them. So you don't need to memorize this sort of shortcut method to figuring out powers of 3 and powers of 4. We're going to show a method that will work for any power. So that method involves what's known as Pascal's triangle. So Pascal was a mathematician quite a number of years ago, and he devised this triangle. And so oftentimes I will add in a 1 at the top of that triangle and then go from there. And I'll explain why in a moment. So if you look for some patterns within the triangle and try to figure out how could I add an additional line to that triangle, what you need to recognize is that the term that is on the row below is just the two terms diagonal above it added together. So 4 results from 3 plus 1. This 4 results from that 3 plus 1. So if I wanted to add another line, you're always going to start with 1. And then I take the 1 and the 4, and that gives me a 5. The 4 and the 6 gives me a 10. 6 and the 4 gives me another 10. And then that gives me another 5. And then we always end with 1. And you could keep extending that triangle forever. You'll always be given the triangle on tests and things, but you may be required to add an additional line depending on the type of question that's asked of you. So you need to understand how to generate another line of this triangle. So how the triangle gets used is that these numbers in the corresponding rows, they match a binomial expansion to a given power. So this first row that I added in with the additional 1, that is actually row 0. And that's because anything to the power of 0 is equal to 1. So when you have that expansion of 0, so if you had a binomial to the power of 0, that's going to equal 1. That's why that's row 0. So then this becomes row 1, row 2, 3, 4, and so on. So whatever the exponent is on the binomial expansion, that tells you which row of the triangle to use. So if my exponent was 5, I would be looking to use this row of the triangle, and so on. So then we're going to walk our way through the step-by-step process of how to then use this row and what do I do with it and how do I actually generate myself to this shortcut. And we're going to talk about that by going through a couple of questions. So the first one we're going to go through is x plus 2 to the power of 3. And I understand that you might be looking at that and seeing the power of 3 and thinking, it's probably faster for me to FOIL. Yes, it might be. We're going through a relatively simple example to kind of get you warmed up with the process. But I guarantee you on anything past 3, the shortcut is going to be faster. Okay, so step 1. We use our exponent to determine which row of the triangle I'm going to use. So this is row 1, because remember the single one at the top would be row 0. This is row 2, and this is row 3. So I'm going to use this 1, 3, 3, 1 row. So what I'm going to do is write down 1, 3, 3, 1. And I'm giving a significant amount of space in between there because that 1, 3, 3, 1, those become the coefficients of my terms in my answer. And you can see that in here. There's a 1, a 3, and an unwritten 1 when it is to the power of 3. So the next step is to identify these as A and B. The individual terms of your binomial, the first one is A, the second one is B. Each of those need to get put behind each of the coefficients. So we'll put an x and a 2 beside each of these coefficients. Okay, so the next step, after you've completed that, is to work out your exponents. So on your A term, the first term will get the highest exponent, which is a 3. Oh, that did not work as I wanted. So 3. So that first x will get a 3. The next x will get a 2. The next x will get a 1. And the final x will get a 0. So you start at the highest power and you work your way down from there. Then the B term gets the lowest exponent, which is 0, and then walks its way up to the highest exponent, which matches the exponent on the original set of brackets. So then once you've completed that, your next step is to work out each of those individual exponents. So we keep our 1. X to the power of 3 is going to give me x to the power of 3. 2 to the power of 0 gives me 1. Anything to the power of 0 is 1. Then we've got 3. X squared, 2 to the power of 1 is 2. Then we've got 3. X to the power of 1 is just x. 2 to the power of 2 is 4. Anything to the power of 0 is 1, and 2 to the power of 3 is 8. So once we've solved all of those exponents, the last piece is to multiply out the 3 terms between each of the addition signs. So 1 times x to the power of 3 times x gives me x to the power of 3. 3 times x squared times 2 gives me plus 6x squared. 3 times x times 4 gives me plus 12x. 1 times 8 gives me 8. Okay, so if you want to break it down into steps, you use the row to determine your coefficients. And then you put in A and B. Then you put in your exponents. Then you solve the exponents. Then you multiply out your terms. And that's finished. So this is your final answer. Note that you should not be able to collect any like terms. The whole point of this process is a shortcut to the final answer without having to FOIL and then FOIL and then FOIL however many times. So you should not be able to kind of collect anything further. Okay, let's go through another example. So this one, we've got 2x minus 1 to the power of 4. So again, we start by selecting our row. So this would be 1, 2, 3. So I'm going to use this row, 1, 4, 6, 4, 1. So I begin by putting those in with large spaces in the middle to fill in all the things I need to fill in. So then I'm going to put in A and B. So I've got A is 2x and B is negative 1. Remember, the symbol needs to go with the term, so don't forget that. 2x minus 1, 2x minus 1, and so on until you finish with the very last term. Next up, exponents. So again, highest power here is 4. So on the a term, I start with that highest power, and then I just walk my way down all the way to 0. With the second term, I start at 0 and walk my way up to the highest power, which is 4. Okay, next step, solve out all of the exponents. So we've got our 1, 2x to the power of 4, 16x to the power of 4, negative 1 to the power of 0, 1, plus 4, 2x to the power of 3 is going to give me 8x cubed, negative 1 to the power of 1, negative 1, plus 6, and that's going to give me 4x squared, negative 1 to the power of 2 is 1, plus 4, that gives me 2x, negative 1 to the power of 3 is negative 1, plus 1, anything to the power of 0 is 1, and then a 1 to finish. So then last bit is to multiply out in between those addition signs. This one you have to pay a little bit of extra attention to because you've got some negatives sitting in there that need to be dealt with, incorporated. So this first term, that's going to give me 16x to the power of 4. Then I have 4 times 8x squared, or 8x cubed times negative 1. So that's going to give me negative 32x to the power of 3. And then the next term, I've got 6 times 4x squared times 1. So that's going to give me plus 24x squared. Next term, we've got 4 times 2x times negative 1. So negative 8x. And then the last term will just be plus 1. All right, and so that is your final answer for this expansion. So again, this is very step by step by step. Follow the steps, put the bits and pieces where they need to go, solve the bits and pieces as you go, and then double check everything because there's a lot of moving parts on these ones. You want to make sure that you get everything where it needs to go and where it should be. Okay, and that does it for this video.